Question 3, vectors question. It says use vector algebra to show that k equals -6, and we know it's a trapezium. So somehow we've got to show that this value here is -6. So we need to find the vector a to d, and we know the vector a to d is parallel to b to c. So because these two are parallel, we know they're going to be a multiple of each other. But we can also work out, what vector b to c is, because vector b to c is just vector b to d plus d to c. So we just need to add those vectors together. So I prefer using column notation to ij notation. So b to c is going to be this, which is 6 minus 9. And as I said before, b to c is parallel to a to d. So we know that this 6 minus 9 is going to equal some multiple of a to d, which is 4k. So b to c is here, a to d is here. So straight away you can see from the top row, what you multiply 4 by to get to 6, you can see it's going to be 1.5. So if we now look at the bottom row, we know that minus 9 is going to equal 1.5k, and so k is -6, as we were asked to show. In part B, let's have a look. What does part B say? Part B says find the length of AB. All right. So the length of AB. Well, first of all, we've got to work out what AB actually is. So if you want to go, we can't go straight from A to B. We don't know what it is. But what we can do is we can go A to D and then D to B. So for part B, to find vector A to B, I would do vector A to D and then add the vector D to B to that. So A to D, we've just worked out what K is. K is -6. So we know A to D is 4 minus 6. And D to B, well, it's just minus B to D. So that's going to be -5 minus 1. Add those together. That's -1 minus 7. And the question says find the length of AB. So the length of AB, just going to use Pythagoras. So it's the square root of -1 squared plus -7 squared, which is root 50, or what's that, 5 root 2? 5 root 2 as a simplified third.